One of the ways that we can actually calculate the Gibbs free energy for a reaction is if I am given the enthalpy of the reaction and the entropy of the reaction. So here I've given you a basic reaction. In this case, the reaction doesn't really matter. It's the enthalpy and the entropy that matters. And also I need to be given the temperature at which this reaction is being run. So we just talked about that. In some cases, the temperature actually determines the sign on the delta G. So if I've given these three pieces, I can use my equation for Gibbs free energy. I always want to take a second and make sure that the units on joules are the same for delta S and delta H. So here it's kilojoules, on delta S it's kilojoules, because sometimes they will report delta S's in joules. So you can see this number is kind of small, so it's very common to report delta S's in terms of joules per mole Kelvin. It's just I need to make sure that these two units jibe. So here I give you kilojoules, everything's good. I need to make sure my temperature is in Kelvin, so if it's given to you in degrees C, I need to be able to turn it into Kelvin. And here I just plug the numbers into this equation. So delta H was given, temperature was given, delta S was given, and I use the numbers, I get a delta G. And remember, if I do things correctly, my units on delta G are going to be the same units on delta H, kilojoules per mole. And in this case, the delta G is negative, so that means this reaction is actually spontaneous.